Okay, now I'm gonna write a diagram of the JavaScript engine. So I told you yesterday, the JavaScript engine contains two things. One is heap, other one is call stack. So they are called execution context. Basically, our whatever the code we have written is this code is going to be divided into small pieces. We're going to divide into small pieces. That small pieces we are going to execute as an execution context. Okay, so these are all the small pieces of code of whatever the code you written. Okay, so it's like a queue system. One we're going to put in plates. See this right in hotels. They're going to keep plates one top of the other, right? Stack of plates. Okay, stack. Okay, the same way. Okay, it's a pile of execution context. One it's going to sit one top of the others like these things. So whenever its turn comes, it's going to execute inside this engine. Okay. Next, another thing is called we have an heap. So this is a place where our all the reference type of data types is going to stores. Okay, so this constitutes JavaScript engine. That's it. JavaScript is that's it, guys. Okay, you can observe there is no asynchronous behavior, right? So yesterday we said asynchronous behavior. So until unless user is going to click button, so we are not going to execute the callback function. But the remaining function we are going to continue, right? This is called asynchronous behavior. Means I'm not going to block another code to be executed. So I'm not going to wait the user still clicks on the click button, then I'll not resume the remaining code execution. I will keep that callback function someplace in web API and I will continue with the remaining code execution. Whenever user clicks, I will call that function. That's it. Okay, this is called non-blocking. Okay, this is called asynchronous behavior. But when it comes to JavaScript engine doesn't know all these things. So if you have a code, it will execute. That's it. If you have a code, it will execute. It's not going to wait or it's not going to hold all these things. So that's the reason JavaScript is a synchronous language. But with the help of web APIs, it behaves asynchronously. It works like asynchronously. Without web APIs, without browser, JavaScript doesn't work asynchronously. Okay. So we call it as an execution context. So these are all small pieces is called execution context. So this is an JS engine. So this is called call stack. This is called heap. Okay. So this is a place where all our code is synchronous or asynchronous. No, it doesn't matter. Everything will be executed inside this place only. That's the reason I told you yesterday. JavaScript is single threaded. It will handles only one task at a time because of we have only one call stack. That's it. Okay. Understood? Any doubts online?
No, sir.
Okay. Yesterday we discussed about compilation and interpretation. Okay. So what exactly it is compilation? What exactly is interpretation? Okay. So when it comes to compiled programming languages, so we are going to write a source code. Everywhere we are going to write a source code. That's everything is in human readable code only. Okay. So everything is human readable code. So that human readable code is going to convert to machine code. Then it will execute inside our JavaScript engine or anywhere. So where the code engine we have, right? Okay. So there. So in the compilation, so the entire if you have written 100 lines of code, all the 100 lines of code is going to convert into a machine code. That's called portable file. Okay, a binary file, zeros and ones. Okay, that file is immediately executes inside our CPU. Okay, so this is called compilation. Let's see the diagram. Okay, so it's a compilation. called interpretation. Compilation. Interpretation. Okay, so we called SRC. SRC stands for source. Source code. So it's a human readable code. So in the step one, the source code is completely converted into we called portable file. Okay, or machine code. So guys, this machine code is completely optimized. Okay, in one instance only it's completely optimized. No need any optimizations. Okay, next, after converting step 2, immediately it's going to execute. After I'll come back to this one. Step 1 and step 2. Okay, we called compilation. Okay, so portable file, then it's going to executes. Okay, program execution. So when it comes to interpretation, okay, so we have a source code. Okay, this, so each line, so it's going to parse the line, first line. It's going to parse the first line. It is converts to the first line into machine code and will execute. So line by line. Only we have one step. Okay. Execution line by line. Okay. It's called program execution. Okay. So when it comes to performance, interpreted languages are less performance than compilation, right? So each and every line we're going to parse it and execute, parse it and execute. It will take a lot of time for execution. But in modern world, so slow performance is not allowed. Okay, so they are introduced called, so now JavaScript is completely changed. It's called JIT, or just in time compilation. So according to JIT, what is exactly it is? So we have a 3 phase also in JIT. Okay, like compilation, we have a 3 phases. Called just in time, or JIT. Okay, just in time compilation. So the entire, so again here the entire code is going to parse, and the entire code is going to convert into an machine code. But this is not a portable file like compilation. Okay, it's an unoptimized code. Means, so basically, so if you have a 10 lines of code, so that 10 lines of code is not going to convert into a machine code. So there is an intermediate phase. Intermediate phase. So each line is called AST, abstract syntax table. Okay, it's completely deep down. Okay, even we don't have any access to all this to see these tables, all these things. Okay, so it's completely wrapped up. Okay, so that abstract syntax table is going to optimize, while remaining code is going to execution in the process. Okay, so we'll see in the diagram. I'll explain with the diagram. We'll understand properly on the time. Okay, so just in time controls. So we have a source code. Next, this source code in the step 1, it's going to converted to, it's also compilation. That's the reason just-in-time compilation as a JIT. Okay. So next, that's converts to machine code, but not a portable file. Like not, it's not like an optimized portable file. Okay. Next, step two, execution. But so program. Okay. So here, so in this compilation, okay. So in just-in-time compilation, so we have a code, right? So clear this one. Not these things. So we have a 10 lines of code, just think, or 9 lines of code. Okay. So 1, 2, 3, 1. So in the first place, so the entire code is going to parse. This all the 9 lines of code is going to parse it. Okay. Once it's parsed, so it's only, so each line of code is converted to AST, abstract syntax table. Okay, each and every line. So it's again one abstraction, one line execution of abstract syntax table is almost around 60 to 70 lines of code in abstract syntax. So each line is going to convert it to and its own memory allocations. Okay, we have memory allocations, variable declarations, everything is going to be stored inside these things. Okay, so and also yeah, because memory allocation is sense, so there we are going to using a physical memory address. So it's going to store all the vital informations of this memory and everything. Okay, what is the operations? So how does it happen? So everything is going to be stored inside this abstract syntax table. So whatever the code is going to convert it to abstract syntax table, so that code is going to execute. In the first place, just think I have only optimized 3 lines of code. Okay, so first parsing. Your code is going to be parsed. Okay, next compilation. Compilation means converting an human readable code to machine code, right? Compilation. Next, execution. Okay, so we have a 3 lines of code. So first it's going to be parsed, it's convert, next it's going to convert it to as abstract syntax table. Next, so that code is going to be converted to machine code. Okay, that is code is going to be converted to machine code, then it's execution. So while executing the 3 lines of code, so immediately I'm going to put an optimized feedback. Optimization. So optimization. So this will take a feedback from this unoptimized code. So we have a 3 lines of code execution, 1, 2, 3. So the remaining 4, 5, 6 will be ready with this optimization. So this is going to optimize your code, which converts a proper AST. Okay. So while done with the 3 lines of code, so the remaining next 3 lines of code will be ready. I'm not wasting, I'm doing parallel works. Okay. So the next 3 lines of code will be, so while executing 4, 5, 6, 7, 8, 9 will be optimizing. Understood? So in that case, so of course I'm efficiently using my time, right? So basically I'm efficiently using my time and code execution, right? So this how it's going to work. Again, it's executing line by line. Observe, it's executing line by line, but optimizely it's executing line by line. Understood? It's executing line by line, but it's optimized completely. Understood? So this type of execution we called JIT, just in time compilation. Yeah, like these things. Okay, see, when it comes to execution, so I will tell you how the execution context will be executed inside this JavaScript engine. So on the time you'll see all these things. So Cubase system only we want to use it. Okay, so this is called JIT. Okay, so this concept might feel like abstract for you guys. Okay, so just have a note of these things. Don't go deep dive if you're not okay. So just have an over glance. That's it. So that's it from here. Hmm? Yes, this is an optimization. You can, I will, you can take a diagram, no issue.
and JavaScript work only on JIT or both verification or JIT?
JIT.
JIT only.
JIT. Earlier is different. Nowadays is modern JavaScript is JIT. Okay, so interpretation is earlier implementation. Okay, so
So,
yeah.
when you're looking at when you're looking overall, what is that called? Yeah. So when you're looking overall at the just-in-time versus optimized feedback, like what does optimized feedback mean?
See, I told you in the beginning. So every code is going to convert into abstract syntax table. Okay, so this phase is only happening for three things, only first three lines. So the remaining three will be happening while executing the three lines. So the remaining 4, 5, 6 will be converted to AST and it's going to compile to an machine code.
Okay, it translates directly into
Yes.
machine code.
Yes.
And it happens it happens in the browser itself.
Yes. Everything is happening inside the browser only.
And then the output is there any output on console log?
Mm-hmm.
Okay. Thank
Okay,
you, sir.
once everything is done, then only we're going to see the result in the console.log.
Okay.
Okay.
And and then that makes sense. Sounds good, sir. Thank you, sir.
Yeah, thank you. Fine. I'm keep on saying execution context. So everything is going to be converted to execution context and it's going to execute inside our call stack, right? What exactly is the execution context? So this is a main piece of information. Okay, so if you understand execution context, understanding closures, working with what do you call it, asynchronous behavior, all will be easy. Okay, let's see this execution context, what exactly it is and what are the things which helps to create execution context. New file or not? Okay, I'll use this one only. Next we'll go further. So I have a code, so I'm going to write a simple logic. Okay, the output of the program is 3, right? Okay. Because see, so actually, typically, when I say the code execution will start from here on. This is the starting part of the code. Why? I would just declare a variable. I'm just written a function. Until unless I'm calling the function will not going to execute, right? So this will not going to execute. This will not going to execute also. Okay. So whenever comes to line number 71, so this is your code execution starts. Okay. So I'm trying to call the first function here in this point of execution line. Okay, so it's going to first function. I will start executing this function. So it will start executing line by line. So I have declared a variable. So this variable is called local variable or a function scoped variable, because this a is only available inside this function, not outside the function, right? So I have declared a variable, but here at line number 58 I am trying to call the second function. Okay, I'm trying to call the second function. Our code is going to pass because I need a value for this variable b, but where do I go to get the value from? By calling the, but after execution of the second function only I used to get the value for the value b. Okay, so this code is going to, so it's going to hold it here. Next, the second function is going to immediately calls. Okay, since I'm planning to return only value of c, so it returns the value of c. What is the value of c? 2 at the point of b. Now b is equal to what? B is equal to 2. I got the value for a and I got the value for b. A is equal to a plus b. Okay, since 1 plus 2 is equal to 3 will be store specs to a only, because this is the reason I declared a with a let keyword. Okay, because I'm reassigning the one of the variable, right? So next I'm trying to return value of a. What is the value of a? 3 at what? So it will return. So this first function will return. So value of a at where I'm calling the function. So where is our function calling happening? At line number 71. So the line number 70 will get the value of 3, and you can go and check. So the output is 3. Understood?
Yes, sir.
Okay, so this is simple code execution. But when I say so execution context, how this code is executing inside the JavaScript engine, we'll see these things. It's completely our approach. Okay, so I will copy this code. So everyone try to concentrate here. So this is the most important operation. Okay, we have a code. Okay, now first thing I'm going to do is like, so what is execution context? So basically it's execution context. So you know about pizza, everyone eats pizza, right? Okay, so when you go to Domino's or anywhere, so they're gonna keep your pizza inside a box, right? They're gonna keep you inside a box. Okay, so the pizza eating is happening inside the box. Okay, actually what is the purpose of box? It's going to helps to eat pizza, that's it. Okay, we have nothing to do with pizza, right? Okay, so it's nothing to do with pizza, but it helps to eat pizza. So if you order a pizza, you'll get a chili flakes, seasonings, ketchups, and all these things, right? And also forks and knives. So whatever the things we need to require to eat pizza, the thing we'll get this thing. See the execution